It is given that what is the largest average velocity of blood flow in an artery of radius 2 into 10 raised to minus 3 meter. If flow must remains laminar, take the velocity of blood as nothing but 2 into 2.046 into 10 raised to minus 3 pascals per second, and viscosity, and the density of blood is given. So the viscosity and density of blood is given, and Rm is to find out the average velocity so that it will be in laminar flow. So we can use the equation related to that velocity, critical velocity, and Reynolds number, that is which is V is equal to Reynolds number into coefficient of viscosity divided by density and diameter. So we can say that it will be laminar up to a value of 2000. So we can take the value of Reynolds number as something but 2000, and the value of coefficient of viscosity, which is given as 2.084 into 10 raised to minus 3 divided by density of blood is given as 1.06 into 10 raised to 3 into diameter, which is radius is given as 2 into 10 raised to minus 3. So diameter we can take it as 4 into 10 raised to minus 3. So if you are putting these values and calculating it, you will get as around 983 into 10 raised to minus 3, or you can take 0.983. And we put all the values in SI system, so we are going to get the answer in meter per second.